Hello viewers, in our previous videos we have discussed the concept of probability distribution, and then we have discussed the concept of a random variable, and in today's lecture we are going to take up the concept of mean of a discrete random variable, right? For those viewers who have not watched the previous videos, they can watch it, and let us start our discussion. So here we are going to take up the concept of mean of a discrete random variable, and let us take the definition. So let x be a discrete random variable, right? And if the probability distribution, here PD means probability distribution, is given by this table, right? And here we see that the random variable x, it takes the values x1, x2, x3 up to xn, and the corresponding probabilities are p1, p2, p3 up to pn, right? Okay, so now we'll define the mean of a discrete random variable, and the mean is defined as sigma of pi xi, right? Pi xi, and where I takes the value from 1 to n, right? So the mean, which is denoted by x bar, and sometimes it is also denoted by e of x, and e of x is called the expectation value, the expectation value of this random variable x. So the mean of this probability distribution is given by sigma of the product of pi and xi, where I takes the value from 1 to n, right? In other words, the mean can also be written as p1 x1. If we take I is equal to 1 here, then we have p1 x1, then we have p2 x2, and then we have pn xn, right? So this is the expression for finding out the mean of this discrete random variable x, right? Now here one important thing is that the sum of all the probabilities, that is the sum of all pi's, that is p1 plus p2 up to pn, is equal to 1, right? Where I takes the value from 1 to n. Clear? So this is the formula for finding out the mean of a discrete random variable. Now let us do some problems. Now let us take this problem. Here the probability distribution of a discrete random variable x is given by this table, and we have to find the mean of the random variable x, right? So here if we compare this information with this information, or this table with this one, then we see that the random variable x takes the values 0, 1, 2 and 3. So x1 is 0, x2 is 1, x3 is 2, and x4 is 3. And the corresponding probabilities, that is p1 is 1 by 5, p2 is 2 by 5, p3 is 1 by 5, and p4 is also 1 by 5, right? Now the mean is denoted by x bar, or the expectation value of x, right? So the mean is given by sigma of px or pi multiplied xi, right? So here I takes the value, see here I takes the value from 1 to 4, so we can write I equal to 1 to 4, right? And we have p1x1, then we have p2x2, then we have p3x3, and then we have p4x4, right? Okay, now substituting the values, here we have p1 is 1 by 5, so we have 1 by 5 times 0, then we have 2 by 5 times 1, then we have 1 by 5 times 2, and then we have 1 by 5 times 3, right? And now we can solve it. So the first term gives 0, this is 2 by 5, then we have again 2 by 5, then we have 3 by 5, right? So if we add all these three fractions, we get 7 by 5, right? So the mean of this probability distribution is 7 by 5, or in other words we can say that the expectation value of x is 7 by 5, right? Now let us take one more example. So here we have to find the probability distribution of the random variable x, and the probability distribution is given here, and we know that the expectation value or the mean of the random variable x is given by x bar, that is e of x, and this can be written as sigma of pi xi, right? And here x1 is 0, x2 is 1, x3 is 2, this is it is x1 is 0, x2 is 1, x3 is 2, and x4 is 3, and x5 is 4, right? And the corresponding probabilities are given here, and see, p1 is 0.1, p2 is 0.25, p3 is 0.3, and p4 is 0.2, and p5 is 0.15, right? So the mean is sigma of pi xi, where I takes the value from 1 to 5, and we can write it as p1 x1, p2 x2, p3 x3, then we have p4 x4, and then we have p5 x5, right? And p1 x1 is see, p1 is 0.1 and x1 is 0, so here we'll substitute the values, plus p2 is 0.25 multiplied 1, then we have 0.3 multiplied 2, plus then we have 0.2 multiplied 3, plus then we have 0.15 multiplied by 4, right? Now this term gives us 0, here we have 0.25, and then we have 0.3 multiplied 2 is 0.6, and 0.2 multiplied 3 is again 0.6, and here we have 0.15 multiplied 4 is again 0.6, right? And if we add all these numbers, we get 2.05, right? So the mean of this distribution is 2.05. Now here we should keep one thing in mind, that the sum of all the probabilities, that is 0.1 plus 0.25, 0.3, then we have 0.2, and then we have 0.15. So the sum of all the probabilities, that is sigma px, must be equal to 1. As we can add these numbers, and we can easily see that the sum is 5 plus 5 is 10, then we have 2 plus 1 3, 3 plus 3 6, and then 9 and 10 and 1, right? So the sum of all the probabilities should be equal to 1. Now let us take one more important example. So here we are given a discrete random variable x, and which has the probability distribution given by this table here, and see, here we have x is the random variable, px is the corresponding probability, and see, this random variable x takes the values 1, 2, 3, 4, 5, 6 and 7, and the corresponding probabilities are given as c, 2c, here we have 2c, then 3c, then c square, then 2c square, then 7c square plus c, and here we wish to find the value of c and the mean of x, right? Okay, so let us do this problem, and here this constant, or this value c, is a positive quantity, and we know that the sum of all the probabilities, should be equal to 1, right? So here we will make use of this result, that is, the sum of all the probabilities should be equal to 1. Clear? So we'll have c plus 2c plus 2c, then we have 3c, then c square, then 2c square, then 7c square plus c must be equal to 1, right? Because all the probabilities should be equal to 1, right? So if we take it as P1, then P1 plus P2 plus P3 plus P4 plus P5 plus P6 plus P7 must be equal to 1, right? Okay, now here we have an algebraic expression. We can simplify it, and 7 plus 2 9 plus 1, that is 10c square, and then we have 2 plus 2 4 plus 1 5 plus 3 8, and then we have 9c equal to 1, right? So we have 10c square plus 9c minus 1 is equal to 0. Now this is a quadratic equation, right? This is a quadratic equation in C, and we can solve it by factorization method. So we can write it as 10c square plus 10c minus c and minus 1, that is equal to 0. So we can factorize it. 10c, here we have c plus 1, then we have minus 1 c plus 1 equal to 0. So 10c minus 1 and c plus 1 is equal to 0, right? Now we have here two factors, and the first one gives 10c minus 1 is 0, so c is equal to 1 over 10, and c plus 1 equal to 0, and c is equal to minus 1. Now we'll reject it, because c equal to minus 1 gives us the negative probability, and we know that the probability lies between 0 and 1. So we'll reject this value of C and we will accept this value of C, that is C is equal to 1 by 10, right? So our first part is solved and find the value of C. So the value of C is 1 by 10, right? Now we have to find the mean of this discrete random variable. So we know that mean is given by x bar, and x bar is the expectation value of x. So this is sigma of pi xi, and where I takes the value from 1 to 7, right? Okay, so here we have p1x1 plus p2x2 up to p7x7, where x1 is 1, x2 is 2, x3 is 3, and so on, right? And p1 is c, p2 is 2c, p3 is 2c, and so on up to p7, that is 7c square plus c, right? Okay, now let us multiply these two terms and add all the products. So p1x1 means c times 1, then p2 is 2c times 2, then p3x3 is 2c times 3, 2c times 3, then we have 3c multiplied by 4, then we have c square times 5, and then we have 2c square times 6, and then we have 7c square plus c times 7, right? So this is c1's a c, then we have 4c, then we have 6c, then we have 12c, then we have 5c square, then we have 12c square, then we have 49c square, and 7c, right? Now again simplifying this expression, we'll get a quadratic one. So 49c square plus 12, that is 61, plus 5, that is 66, right? So we have 66c square plus we have here we have 1, so 4 plus 1 5, plus 6 11, plus 12 is 23, and 23 plus 7, that is 30c. So the mean is given by 66c square plus 30c. Now we have already obtained the value of c as 1 by 10. So if we substitute c is equal to 1 by 10 here, we get 1 by 10 square, then we have 10 times of 1 over 30 times of 1 over 10, right? So we have 66 divided by 100, 10 square is 100, then we have this is 10 3s are 30, so here we have 3. Now 66 divided by 100 is 0.66, plus we have 3, so this is 3.66, right? So the expectation value or the mean of this distribution is 3.66, right? Now let us take one more important example. So here a discrete random variable x has the probability distribution. Now the distribution is given by this table, and here we have x, the random variable, and it takes the values 1, 2, 3 and 4, right? And the corresponding probabilities are k, 2k, 3k and 4k. And here we know that the value of k should be positive, because probability is always positive, and here k should not be equal to a negative number, right? Okay, so let us start, and here our first aim is to find the value of k, right? So we know that the sum of all the probabilities, the sum of all probabilities should be equal to 1, which can be written as sigma px is equal to 1. It means p1 plus p2 plus p3 plus p4. If we take this as p1, this as p2, this as p3, and this as p4, right? And we can take this as x1, this is x2, this is x3, and this is x4, right? So the sum of all the probabilities should be equal to 1, and we have k plus 2k plus 3k plus 4k should be equal to 1, and this is 4 plus 3 7 plus 2 9 plus 1 10, k equal to 1, so k is 1 over 10, right? So once we have obtained the value of k, now it is very easy to find these two parts, and let us take the second part. So here we have to find p, that is the probability, those probabilities for which x is greater than or equal to 3, right? So this can be written as p of x is equal to 3, because here we have the equality sign, then we have x equal to 4, right? So p of x greater than or equal to 3 is p of x equal to 3 and p of x equal to 4. Now p of x equal to 3, that is the probability which is corresponding to this value, that is x equal to 3 is 3k, and the probability which is corresponding to x equal to 4 is 4k, so we have 7k, and the value of k is 1 over 10, so this is 7 times 1 over 10, that is 7 by 10, which can be written as 0.7, right? And this value can also be written as 0.1, right? Okay, now the third part is to find the mean of x. Now we know that the mean of the discrete random variable x is denoted by x bar, which is also known as the expectation value of x, and this is sigma of pi xi, where I takes the value from 1 to 4, right? And the mean is p1 x1 plus p2 x2 plus p3 x3 plus p4 x4, right? And p1 x1 is k times 1, then we have 2k times 2, then we have 3k times 3 plus 4k times 4, and this is k plus 4k plus 9k plus 16k, right? So this is 16 plus 9 25 plus 4 29 plus 1, that is 30k, and the value of k is 1 by 10, so we have this is 10 threes, so the mean of this distribution is 3, right? And the value of k is 0.1 or 1 by 10, and the value of p of x greater than or equal to 3 is 0.7, right? Now let us take one more example. So here a discrete random variable x has the probability distribution given by this information. So x takes the value 0.5, 1, 1.5 and 2, and the corresponding probabilities are k, k square, 2k square and k. And again here we see that this k must take the positive value, right? Okay, Now here we have to first find the value of k, so we'll again make use of the result that the sum of all probabilities should be equal to 1. It means sigma of px must be equal to 1, and if it is p1, this is p2, this is p3, this is p4, and this value is say x1, this is x2, this is x3, and this is x4, right? So sigma of px equal to 1, it means sigma of pi is equal to 1, and I takes the value from 1 to 4, so p1 plus p2 plus p3 plus p4 must be equal to 1, right? So the sum of all probabilities should be equal to 1, and p1 is k, p2 is k square, p3 is 2k square, and p4 is k, that is equal to 1. So here we have 3k square plus 2k equal to 1, and again here we'll have a quadratic equation in k, right? So this is a quadratic equation. Now this equation can again be solved with the help of factorization method. So we can write 3k square plus here we have 3k minus k, so splitting the middle term, and we have 3k, then we have k plus 1, and then we have minus 1, and here we have k plus 1 equal to 0. So k plus 1 and 3k minus 1 is equal to 0. So here k plus 1 equal to 0 gives us k is equal to minus 1, and 3k minus 1 equal to 0 gives us k is equal to 1 by 3. Now this is a negative value, so we reject it. So we'll reject k equal to minus 1 because it gives us the negative probability, right? So we'll reject it and we'll accept this value, right? So the value of k is 1 by 3, right? Now we have to find the mean of this distribution. So the mean is given by x bar, that is also known as the expectation value of x, and this is sigma of pi xi, right, where I takes the value from 1 to 4, right? Okay, so here we have p1 x1, then we have p2 x2, then we have p3 x3, and then we have p4 x4, right? Now p1 x1, now p1 x1 is k times 0.5, then we have p2 x2, that is k square times 1, then we have p3 x3, that is 2k square times 1.5, and then we have p4 x4, that is k times 2. Clear? Now k times 0.5 can be written as k by 2, and we have k square here, then we have 2k square times 1.5, that is 3k square, right? And then we have 2k. Now this is 3k square plus k square is 4k square, and k by 2 plus 2k is 5k by 2, right? So the mean of this distribution in terms of k is given by this expression. Now k is 1 by 3, so we'll substitute k is 1 by 3 in this expression. So the mean x bar is equal to 4 times 1 by 3 square plus we have 5 by 2 times 1 by 3, and this is 4 by 9, and this is 5 by 6, and if we take the LCM, then we have 18 as the LCM. 9 2s are 2 4s are 8, 6 3s are 3 5s are 15, and this is 23 divided by 18. So 23 divided by 18 is the mean of this distribution, right?